Hi, welcome to this video. Today I will talk to you about our paper about finding episode rules in sequence of events. So in this paper we try to find a new type of rules to try to explain the relationship between events, and we use a measure called the head support. Okay, so I will explain to you why this is interesting. So let me give you first a brief introduction. This paper is about data mining. We have a sequence of events that looks like this. So here we have some events called A, B, C, D, and we have the time from left to right. Here we have the different timestamp like T1, time 2, time 3, time 4, and so on. So what this sequence means, we have over the time some events like AC at time 1, followed by A at time 2, AB at time 3, time 4, 5, 6, and so on. So if we have the sequence like this, it is, for example, a sequence of events, maybe in a computer system, or it could be the sequence of what the people buy in a store. We can try to analyze this data to find the patterns like we call episode. The frequent episode means some sequence of events appear many times in your data. And if you find these patterns, it can help you to understand your data, understand why some events appear always before some other events, for example. So there is a classical problem in data mining called the frequent episode mining. So given as input a sequence of events with timestamp, we want to find the episode that appear many times. An episode is a subsequence like A and B together followed by C. Okay. So here, for example, A, B followed by C appear in the sequence at between time 7 to 8. So there are different types of episodes we can find, and usually we need to set a parameter like the window. So we want the episode like AB followed by C to appear within some maximum amount of time. So there are many algorithms. Here I list a few of them. We set the parameter the minimum support, and the algorithm will tell you all the episodes appear at least this minimum number of time in your data. So now there is some limitation about this. If you find the episode appear many times in your data, maybe it just appear by chance. So to solve this problem, some people have extended this to find the episode rule. An episode rule means if you have some events like A followed by C followed by B, then it implies that later there will be the event D, okay, shortly after. So this is a rule like X imply Y. If there are some event X, some events, it will be followed by another event, likely. It will be highly likely that it will be followed, okay. It will appear after. So we use two measures to find the rules like this, called the support. The support means how many times the rule appear, and the confidence means like the conditional probability. So the confidence of X imply Y is how many times we have X followed by Y divided by how many times we have X. So here, for example, for the rule ACB imply D, it appears here between time 5 to 8. Okay. So there have been many papers about finding episode rules in the sequence data, different kinds of rules like the utility-based episode rules, the precise positioning episode rules, and other type of rules. Okay. So In this paper, we will introduce a new type of rule that we hope will give better result or will be more interesting. So before I present the new type of rule, let me introduce some definition, okay? So if we have an episode like ABC, we can look at the occurrence of ABC, where it appears in the sequence. So A, B, and C appear between time 1 and 2, for example, A, B, and C in any order. Between time 5 and 7, we have A, B, and C. And between time 10 to 10, we have A, B, and C together. So these occurrences, T1 to T2, T5 to T7, and T10 to T10, we say they are the occurrence of ABC. So we say also that those are not overlapping, okay? So these occurrences are non-redundant, means they don't overlap over the time. So now, in this paper, based on this definition, we previously proposed the concept of partially ordered episode rule, a new type of episode rule. So what is special about this rule, very briefly, is that the left side of the rule, there is no order, and the right side of the rule, there is also no order. So let me just show you an example briefly. We have the rule like this. That means ABC in any order will be followed by some even D. So this is different than other types of rules, because usually we will have A followed by B followed by C with some order. But here, to be more general, we remove the order. So A, B, C in any order will be followed by D. So we designed this algorithm we propose in the ACIDS conference, and we say that this rule, like ABC followed by D, appear between time 1 to 3 and 5 to 8, because we want the occurrences that are not overlapping, as I just explained. So now, in this paper, we want to change a little bit this definition, because we observe that our rule, the POER, the partially ordered episode rules, sometimes they don't give the good result, because we require that the occurrences are not overlapping. But in some case, it gives the strange results when we use this definition of occurrence. So here we use an alternative definition called the head support. So the idea is, I will try to explain in a simple way, we want to find the occurrence that might overlap but don't start at the same time, okay? So let me show you an example. If we look at the occurrence of ABC, okay, the item set, the set of events ABC. So here we have A, B, C. We will have two occurrences, even they overlap, because they don't start at the same time, okay? So we will have one occurrence of ABC start at time 6, and another occurrence of ABC start at time 7. And we count this twice, okay? So in the other definition before, we will keep only one occurrence, because these two occurrences are overlapping. But here we want to count separately, because they don't start at the same time. This is the main idea with the head frequency. So in this paper, we had previously one algorithm called POERMH to find the episode rules, and now we change the definition of the support. So we call this POERMH for the head support. So the algorithm is a little bit similar, but we change the definition of how to count the occurrence. So how the algorithm works. First, it will try to find the antecedent of the rules, the left side of the rule that appear many times. And then it will try to make the rules by combining this with the right side of the rule. So here I will skip the details about this. And if you want to know more about how the algorithm works, you can have a look at the paper. So now we want to test our new rule for the task of sequence prediction to see if these new rules are better than the other rules from other paper and our rules we used before. So, for what is sequence prediction? It means you have a sequence like this, and we observe some events we call the prefix. So here I observe some events A, C, B, and I want to predict what will happen after in the suffix. Okay, so let's say I don't know what will happen after. I want to predict what will happen after A, C, B. For example, D. If I say D, it will be a good prediction. Okay. If I don't say D, it will be a bad prediction. Or maybe I don't know how to make a prediction, so I cannot make the prediction. So what we will do, we will use our new rules to try to do the prediction, and we will compare with the other type of rules to see can we make the better prediction. So we'll use two measures. The first one is the accuracy, the number of good prediction divided by the total number of opportunities to do the prediction. And the matching rate, which is the number of good or bad prediction divided by the number of prediction opportunities. So that means how many times we were able to make some prediction, but on the number of opportunities. Because sometimes also we don't have the rule. We cannot make the prediction. So to do the evaluation, here we use two databases. These are the text, the books, okay, the Bible and some novel. So we use some timestamp we generated, and we have the events, they are the words in the text. So we set the parameter as follows, and we try to do the prediction. So here what we did, okay, we compare our new algorithm, POERMH, with the head support, with our previous algorithm, POERM. And we want to see which one has the better results. So here we use different values for the parameter, okay. So this is the confidence, okay. So we have two database, A and B is for the two database, and we have the accuracy and the matching rate based on the prefix size. Prefix size means how many events we look at to predict what happened after. So here what we can see, our new rules here, they achieve the better prediction than the rules we had before. Okay. And here, if we use the confidence higher, 70%, also we have better accuracy than if we use our previous definition. And the same for the matching rate. We find that using the new measure for the support, the head support, we get better result for accuracy and matching rate for the two datasets. So this is just some brief overview about our paper. In this paper, we look at the sequence of events. We try to find the episode rules to try to understand the relationship between the events in the sequence. And before, in previous paper, we designed the partially ordered episode rules, but here we changed the definition of occurrence, how to count the rule when it appears in a sequence. And we did some experiment to test for the sequence prediction to see can we get the better prediction. And we found that yes, using this improved algorithm with our new definition, we have the better results. So one thing to say is here we don't compare with the machine learning model like the neural networks and so on, because this is a different type of approach. Okay, in episode rule mining we try to find the patterns we can understand by the humans. So if A, then it will be B after. Okay, these are very easy to understand. But of course, for the accuracy, it cannot compare with the machine learning models and so on. If you use a neural network, maybe you get the more accurate prediction. But the neural networks usually are the black box. It gives the good accuracy, but you don't know why. Okay, so here is a different type of approach. We want to find the patterns we can understand and also give some quite good accuracy, but maybe not the best. So this just to explain the difference, okay, between these approach and why we don't compare with the machine learning model. So in future work, we could add some more optimization and also consider the more complex data types. If you are interested by this work, you can read our paper and also check our SPMF data mining software that will give you the code and the data if you want to try these algorithms on your data. It is open source. You can download the code and also many other algorithms to analyze the data. So that's all for this talk. I hope it has been interesting. Thank you.